Welcome to the AI Research Roundup. I'm Alex, and today we're looking at a paper from the Hugging Face trending list, published on June 26, 2025. Published just a few days ago, this paper introduces a model that achieves a top overall score of 73.4 on a new multi-subject benchmark. The paper is titled XVerse Consistent Multi-Subject Control of Identity and Semantic Attributes via DiT Modulation. It tackles the tricky problem of getting multiple, distinct subjects into one generated image, giving users precise control without the usual distortions or mix-ups. Also, the authors shared their official implementation on GitHub. If you check it out, you'll find the source code, checkpoints, and detailed instructions to get everything running. They've even included scripts to launch a local Gradio demo, which is a fantastic way to experiment with the model yourself. On the Hugging Face page, you'll find the official XVerse model weights ready for download, along with usage examples to help you get started with the code. Alright, so let's dive into what makes this model special. The first figure here really showcases the power of XVerse. We see images with 1, 2, and even 3 distinct people, all keeping their identities consistent with the small reference photos. The model's core technique is text stream modulation inside a diffusion transformer, which is a powerful type of architecture for creating images. This modulation method injects subject-specific details without disrupting the rest of the image. The bottom images then demonstrate fine-grained control over other attributes, like a person's pose or an object style. Building on that idea, this figure gives us a look under the hood at the XVerse framework. On the left, you see the inputs, separate reference images for a man and a shirt. A special DiT Mod adapter processes these images and creates targeted adjustments. These adjustments are then precisely injected into the diffusion transformer, specifically targeting the parts of the text prompt for man and shirt. Additionally, to capture fine-grained details, it uses a variational autoencoder, or VAE, a network that helps encode and reconstruct images to add extra visual information without causing distortions. Okay, so this next figure really puts that framework to the test, showing a qualitative comparison, which is basically a visual showdown with other models. You can see the inputs on the left, reference images and a prompt. XVerse's results are right next to them. In every case, especially with multiple subjects, XVerse just nails it. For instance, with the man and the woman, their identities are kept distinct and accurate. Other models struggle, often blending faces or losing the likeness. The last row with 3 different animals is especially telling. XVerse handles it, while the others fall apart. Alright, so moving from the visual evidence to the hard numbers, this table lays out the quantitative results on their new XVerse benchmark. It compares XVerse against several other methods for both single and multi-subject generation. They use a few key metrics here. For instance, IDSIM measures how well a subject's identity is preserved, which is crucial. Looking at the numbers, XVerse achieves the highest overall score of 73.4. It really pulls ahead in the challenging multi-subject tests, getting the top scores for average performance and for that all-important identity similarity. So a big reason for those strong scores is a clever training technique shown here, called region preservation loss. During training, the authors combine 2 different images. As you can see, they apply specific subject changes, like for the woman in her purple shirt, to only one side of the combined image. The model is then penalized if it accidentally changes the other side, the one with the man. This penalty, which is an L2 loss, basically a way of measuring pixel by pixel difference, forces the model to learn precise, isolated control. So, that clever training strategy is a big piece of the puzzle. In conclusion, XVerse really pushes the boundaries for multi-subject image generation. Its core idea, using targeted modulation inside a diffusion transformer, allows it to precisely control individual subjects without causing the usual artifacts or identity blending we see in other models. The results, both visually and in the benchmark numbers, are truly impressive. It's a significant step towards creating complex, coherent, and highly editable images. That's all for this paper. Thanks for tuning into the AI Research Roundup.